for this screencast, we're going to take a look at an activity that's described in the 4th edition of The Practice of Statistics. This is found in Chapter 10, Section 2, and it's an activity involving comparing two means. So this activity takes a look at how quickly synthetic fibers decay in landfills. And a researcher buried 10 strips of polyester fabric in well-drained soil in the summer. 5 strips of the fabric were buried for 2 weeks, and another 5 strips of fabric were buried for 16 weeks. At the end of that time, the breaking strength of the fabric in pounds was measured, since breaking strength is a good indicator of decay. Here we can see that the mean for the first 5 strips, the group 1 that was in the ground for 2 weeks, the mean for that group was 123.8 pounds, and the sample mean for group 2 was 116.4 pounds. So that's a difference of 7.4 pounds. So you might look at this particular set of data and think, okay, the fabric has decayed more. However, is this difference alone likely to happen by chance? Is there enough evidence to conclude that polyester decays when left in the ground for longer periods of time? So the textbook describes how you could use index cards to do this simulation by hand, but we're going to do this simulation with Fathom. And here we can see I've created a collection called Decay, and there are 10 observations in this collection with the variable called break strength. And break strength is these 10 values that we see listed on the right for the two groups. So if time in the ground had no effect on breaking strength, then each of the 10 strips would have had the same breaking strength regardless of whether it was assigned to group 1 or group 2. So we are going to randomly select 5 of the 10 from this list and assign them to group 1, and the remaining 5 that are left behind that are not selected will be assigned to group 2. So let's see how we can do that. So I'm going to right click here on Decay, and I'm going to say sample cases. But I don't want to sample 10 cases because I don't want to sample all 10 of the items that we have here. We only want to sample 5, and we want to do this without replacement. Once we've drawn one, we don't want to put it back in the pile. We don't want to necessarily draw it twice. So let's take a look at what's happening here. We'll click on the Cases tab, and we can see that 5 values have been selected. And if I go back here and sample more cases, we can see that a different 5 values have been selected. So we have 5 values. We could calculate the mean of those, but let's have Fathom do the work for us. So we're going to create 3 different measures here. The first one is the mean for 2 weeks. So these 5 that we're selecting here at random, those will represent the 5 that are randomly assigned to group 1. And so all we have to do here is calculate the mean break strength for those 5 that were selected. So for that particular set of 5, the mean was 123.4. And for this group that I just selected, the mean was 126. Or excuse me, 124.6. 126 was one of the cases. All right, let's take a look at a formula for calculating the mean for 16 weeks. And then we'll do one for the difference between the two sample means. Well, if you think about it, there's got to be a way to calculate this. I mean, we've chosen 5 of these values, and those 5 had a mean of 124.6. Let's see, maybe we can figure out the mean of all 10 of these. So let's grab a summary chart here and see if we can figure out the mean of all 10 strips. Okay, the mean is 120.1. Well, we have 5 strips that we've chosen, and we have a mean for those. And then there's 5 strips that we haven't chosen, and we'd have a mean for those. Let me think here. So essentially, I want to take the sample mean for group 1. If I was to take the sample mean for group 1 and the sample mean for group 2 and average those, I should get our overall sample mean of 120.1, since the sample size for those are both 5, since we have 5 in each group. The average of the two averages here should be 120.1. So I have a number here that's being calculated by Fathom for the sample mean of group 1. Let's see if we can get the formula in here. So essentially, if I was to solve this equation for sample mean of group 2, I'd multiply both sides of my equation by 2 and then subtract the sample mean from group 1. That sounds like it's a good idea. So we're going to have 2 times 120.1 minus the mean for 2 weeks. So that's the mean for the first group. Okay, and we could do a quick check here. We could see if we average 124.6 and 115.6, do we get 120.1? And we do. So that looks good. All right, and then the difference here is a difference between these two sample means. So we have mean 2 weeks minus mean at 16 weeks. All right, so there that difference is 9, and I can see there that the difference is 9. Let's actually collect some measures. So I'm going to close this inspector here, and I'm going to collect some measures. So basically the simulation here is randomly selecting 5 values, calculating the mean for those 5 values, and the mean for the 5 values that are left behind, and figuring out the difference between those. And it did that 5 times here. Let's actually take a look at a scatter plot of this, of these differences. Okay, there's our scatter plot of the differences. Let's now take a look at doing this a few more times, because 5 is not really a good idea of, it doesn't really give us a good indication of what's going on. So let's turn the animation off, and let's collect 95 more measures. And Fathom does that fairly quickly. Let's collect actually maybe another 400 measures. So now we'll have a total of 500 measures here. And here we can see that the center of our distribution is very near 0, which would indicate that there is really no difference between those two sample means. And a sample mean of 7.4 occurred right around here, and we can see that a difference of 7.4 is fairly likely to happen by chance. Either that value or more extreme is likely to happen by chance. So I think we've answered our question here. Is this difference likely to happen by chance alone? Definitely. And is there enough evidence to conclude that polyester decays when left in the ground for longer periods of time? Well, we can see that there's quite a bit of variation here. And as a matter of fact, a lot of the values were centered around 0 here, indicating that there really is no difference between the mean breaking strength for the two groups.